Hey everybody, it's Miss Kent, and today we're going to continue talking about fractions on a number line, but today we're going to talk about comparing fractions on a number line. So we're going to be looking at two different fractions and comparing them, okay? So first of all, if you don't have a piece of paper and a pencil, please get one because you're going to need to draw some of these lines to practice. We haven't had a lot of practice with this skill, and our next lesson is going to involve actually using a ruler to measure something to the nearest fraction. So I want to make sure that you understand how to draw a number line. Okay, so go ahead and if you don't have paper and a pencil, stop the video and go get one. Hey, grab some colors too, like some colored pens or crayons. Okay, on our first number line, if you have paper with lines on it, it's very helpful because you can just trace that line. And right now we're going to use our pencil. Our number line is going to start with 0, and it's going to end with 3. Start with 0, and it's going to end with 3. Okay. And we're going to add, should something come between 0 and 3? Yes, 1 and 2. So with your pencil, go ahead and add a 1 and a 2. One and a 2. Now for my first one, I'm going to pick any color, but I'm also going to use my pencil. Now if I'm writing with a pen, it's okay to completely write with a pen. But if I'm writing with a crayon, it's kind of hard to read. So first, let's use our pencil before we start using any color, okay? So we're going to label this by 6th to start with. 6th, okay? Take your pencil so that you can erase if you need to, okay? I know that I would start right here and I would label this 0, 6th. So with your pencil, right under that, 0, 6th. Now 1 whole would be the same as 6, 6th. And 2 wholes would be the same as, if 6 sixths is 1 whole, 2 wholes would be 12 sixths. And 3 wholes would be 6 times 3 is 18 sixths. So already I've numbered some of these fractions on my number line. Now let's go back to our pencil here. Okay, and what have I said is a good starting place or a good landmark fraction? And if you don't remember, half is always a great landmark fraction. So between the 0 and 1, I'm going to divide that into half. Now, if this is divided into 6th, half of this will be divided into how many pieces, and this half will be how many pieces? So we're looking at 3 pieces and 3 pieces. Does that mean 3 lines on each side? No, because a fraction is not the actual line, it's the piece. So go ahead and draw and make sure when you count pieces. 1, 2, 3, 4, 5, 6 pieces. Draw that with your pencil, please. Now I want you to take your crayon, or if you have a colored pen with you, and pick any color. I've chosen green. And go back over these and trace over these with that green color. So I would have, I'm erasing mine because mine won't show up as good if I don't trace over it. If I trace over it. So now I have the 6th, and I'm going to label these fractions, and I'm probably going to use my pencil, or if I'm using a pen that would be okay too, but it's kind of hard to write with a crayon because we're writing so small. So this would be 1 6th, 2 6ths, try to bring this computer as close as I can, 3 6ths, 4 6ths, 5 6ths, then I've hit 6 6ths. So then I'm going to go to my next between 1 and 2, and I'm going to take my pencil And what's that good landmark fraction? Half. And remember, if I cut that unit in half and I have sixth, I need 3 on one side and 3 on the other. 3 lines? No, 3 pieces. I'm going to go back and count. 1, 2, 3, 4, 5, 6. And then, and if you need to stop this video at any time because I'm going too fast, please stop it and label yours correctly. Then I'm going to go back and I'm going to take my green or whatever color you're using, just stick with that same color. I'm going to draw my lines. And then I'm going to take my pencil, or if I'm using a pen, now if I'm using a crayon, it's not that easy to write with a crayon, and I'm going to label these. 7/6, 8/6, 9/6, 10/6, 11/6, and 12/6. If you don't have these labeled, please stop the video now. I want you to, if you do have them labeled, to go ahead and label between 12/6 and 18/6. Draw your lines and label that number line. So please stop the video, pause it and finish filling this in, and then go ahead and fill that in also. Make sure that you're dividing it into the 6 pieces and labeling them. If you haven't stopped the video and finished this piece, please do that now. Okay, so remember, good landmark spot is the halfway mark. I'll need 3 pieces on each side. Not 3 lines, but 3 pieces. This would be 13/6, 14/6, 15/6, 16/6, 17/6, and 18/6. Uh-oh. 14, 15, 16, 17, 18. Where did I mess up? Because I see I have 18/6 and 18/6. What did I do? You know what I did? I used that halfway mark and I did exactly what I told you not to do. I drew how many lines? 3 lines. Did that make 3 pieces? No, it made 4 pieces. So I need to take one of those off because that's not correct. So now I have 13/6, 14/6, 15/6, 16/6, 17/6, 18/6. I'm glad that I started out by labeling those holes because I knew when I got to that hole if it was incorrect, because as I counted up, I got here and I had 18/6 and 18/6, and that didn't make sense. So I'm glad I started out labeling my holes. Now directly below this, I want you to draw another number line. And if you're using lined paper, below where you've written, skip 2 or 3 lines so that there's space that you can write above this. And I'm going to label this one the same, starting with 0, and I'm using my pencil, and ending with 3. Using my pencil. Now I'm going to try my very best, and if you need to stop this video at any time to catch up with me, please do, to line up the 1 and the 2. So I'm going to kind of like line them up. Here's 1, and here's 2. If I'm lining these up, it'll be easier for me to visually compare these fractions. This time I'm going to label my number line with fourths. Fourths. So I know 0 would be 0/4. 1 would be 4/4. 2 would be 8/4. And what would 3 be? 4, 4, 8. Oh, 12/4. Now pick out a different color than green for you to use for this one. Sometimes color coding is a great visual for us to see the different size pieces of a shape. Okay, if we're dividing this into fourths, how many pieces do I need? That's right, 4 pieces, okay? What's that good landmark fraction to try to start with if you can? Half. Now that's only 2 pieces, so I need to divide each of these in half. 1, 2, 3, 4 fourths. Now I'm going to go back with my red crayon. Okay. And then if you're using a crayon, get your pencil and let's label this 1/4, 2 fourths, 3 fourths, 4 fourths. Okay. Between 4 fourths and 8 fourths, I need how many pieces? 4 pieces. What's that good landmark fraction to start with? A half. Now you see, I'm trying my very best to line these up because I'm going to be comparing these fractions. And then I need to know half of a half is a fourth. So here's 4 fourths, here's 5 fourths, 6 fourths, 7 fourths, 8 fourths. Go ahead and stop the video and finish this for me. Remember, we're dividing it into fourths. Okay, so I have 8 fourths, 9 fourths, 10 fourths, 11 fourths, and 12 fourths. And I'm so glad I had written those whole numbers up there because that kind of helps me make sure that I'm on the right track. Do you see how I wrote this one below and this one above? Does it really matter if you number your number line above it or below it? No, it really doesn't matter because they're still going to have the same value. This still equals 1 here as it does here. However, I numbered mine this way because I can easily look to compare these. If these numbers were down here, it might be harder for me to visually compare. But I am going to add a third number line to be comparing. So go down here and skip, 3 or 4 lines and go ahead and draw your third number line. And it's going to start with 0 and it's going to end with 3 also. If you need to stop the video to do that, please do so. And then I'm going to have a 1 and a 2. This time I'm going to number my number line using thirds. I want to number above again because it's going to just kind of put it closer together here. So if I'm going to labeling by thirds, 0 would be 0 thirds. 1 whole would be 3 thirds. 2 wholes would be 6 thirds. And 3 wholes would be 3, 6, 9 thirds. Okay, so I need to divide each of these pieces into 3. Now I know I've talked about starting with half is a great landmark fraction. If I start with half here, I already have 2 pieces and I need 1 more piece. Would it be okay if I just put it right there? No, because with a fraction, each piece needs to be the same size for them to be equal pieces. This is a case where half is not a good starting. Well, let me take that back. We can use half. Okay? But we have to think about 3 equal pieces. So this half might be a good landmark place for us to think about. Okay, I want 3 equal pieces. So that means on this side I would have 1.5 pieces. And over here I would have 1.5 pieces. Okay, whew. So I'm going to start in the middle. I'm going to think about, does that look like 1.5 and 1.5? I think it does. 1/3, 2/3, 3. I think that half mark kind of helped me. And I'm going to take I chose blue this time, choose a different color. And I'm going to draw my lines and I'm going to label this. 1/3, 2/3, 3/3. Now, once you get older, it's kind of easier just to eyeball it and know what thirds are. But until you get to that point, you can use that halfway fraction and think about, I need 3 pieces. So 1.5 pieces will be on this side and 1.5 on that side. So then you'll kind of draw your lines and take that half away. So 3/3, 4/3, 5/3, 6/3. And go ahead and stop the video and finish this line yourself. Okay, I want to use these number lines to compare some fractions, and I've drawn all 3 number lines to help me. These are just like the pieces that we cut out, except remember on the pieces we just cut out 1 hole, 1 hole, 1 hole to compare. Here I have 1 hole, 2 holes, 3 holes. Okay, so the first fraction I want to compare would be, let me get a better marker, I'm sorry. 4/3, and I want to compare it to 7/4. Now this is kind of hard to compare because we've talked about comparing fractions with the same numerators on top, and I'm sure your parents have talked about comparing fractions with the same denominators. But here we have different numerators, the top number, and different denominators. So I'm going to look at my number line, 4/3. I'm going to put a point there. 7/4. What can I say about these 2 fractions? 4/3, how can I compare it to 7/4? 4/3 is less than 7/4. Let's do another one. What about 14/6 and 7/3. Now these are on this line to this number line, and kind of look visually with your eyes. Maybe you have something like here, I have this notebook and I can kind of line it up. Do they actually line up? Let's look. How could I compare those 2? Which one's greater? And actually, these 2 fractions, if I line it up and if I had a pencil, I might do this. These 2 fractions would be considered equivalent or equal. Does anybody see something with the numbers here, a relationship between 14/6 and 7/3? Hey, I do. If I double 7, that's 14. If I double 3, that's 6. So let's see if they truly are. I want to go back to that tape diagram. I'm really good with that tape diagram. And sorry, mine. You see that real good? Okay. So this would be the 3 side. Well, excuse me, I'm thinking of the area model. I need to go back. These will be my 3 pieces, excuse me. Now listen carefully because this can get confusing. This is piece number 1. When I say this is piece number 1, I mean piece number 1. This is piece number 2. That would be between the numbers 1 and 2. And this is piece number 3. Okay? Each of these pieces was divided into thirds first. So let me divide it into thirds. Oh, they're not equal, I'm sorry. This is 3/3, 6/3, 9/3. So my first fraction is actually 7/3. So I'm going to go ahead and color in 7/3. Like I said, they're not totally equal. And there's a reason I'm not coloring them fully in, because I want you to be able to see this visual. So this is 6/3. And here's 7/3. So that's 7/3. Okay. Now my other fraction here, I had 1 piece, 2 pieces, and 3 pieces. However, with this fraction, it wasn't divided into thirds. Each piece was divided into 1/6. So here I have 1, 2, 3, 4, 5, 6/6, 12/6, 18/6. Now let me count all the pieces I shaded in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these pieces are equal. So as the pieces got smaller, they halved the pieces. Now here's what's confusing. I know in our number talk we were talking about doubling and halving, but when we half fractions, what happens to the pieces? The number of pieces get bigger, but the pieces are actually getting smaller. So when we talk about halving a number, we're talking about taking half of it, not the whole thing. So when you see a 6 is half of a third, you can see back here from our model that here's a third, and right here's where 1/6 would be. So when we half a fraction, the actual denominator, the number gets larger, but the piece is getting smaller. Okay, I'm going to try to explain this one more way. When we're counting up, the numbers are getting larger. You see 0, 1, 2, 3. When we have a fraction, when we have a number like 2 and we divide it in half, it's 1, we go backwards on the number line. When we have a fraction like 1/3, and we divide it in half, we go halfway back on the number line, and that becomes 1/6, because now it takes 6 pieces to make up that whole. I know this is a lot to think about because it is hard to understand the difference between halving whole numbers going back and halving fractions of a number, okay? Okay, let's look at one more on our number line. What about, let's compare 11/6 to 5/3. 11/6 to 5/3. These are pretty close. But which one's greater? 11/6 is greater than 5/3. Okay, I know this has been a real deep lesson on understanding fractions, and if we were in the classroom, we would be taking we would be spending a lot more time on this. I hate that it's cut short. If you have any questions, you can always feel free to ask me those questions. We're going to have a word problem of the day, and then we'll be done. And our word problem today is going to talk about swimming. And I know a lot of us are ready for it to be warm and we can swim. It's kind of hard to believe we're having another little cool spell here, but also I hope that we'll be able to go swimming this summer, that everything will be back to a somewhat normal and we'll be able to enjoy spending time with each other. So Sam sees a black line on the bottom of, it's not, yeah, on his pool, on a pool. Okay. Now, most of us when we go swimming, we don't see a black line on the bottom of a pool. Can anybody think, using their background knowledge, when or where would you see a black line on the bottom of a pool? Maybe in the Olympics when people are swimming, or maybe if you, I don't know of any Olympic-sized pool here. If you go to the Athens City pool, I know they have swim teams, so I bet they have it there. The lines on the bottom of the pool are kind of like the lanes. If you're ever running on a track, you'll see there's lanes. So in a swimming pool, when you're in a swimming competition, you have your lane you stay in, and you want to stay in your lane so that you don't affect someone else's time on their swimming. Also, if you swim straight, you're going to get there faster, versus swimming at a curve, you're not going to get there as fast. So if you're swimming in a pool with a black line on the bottom, it's probably some kind of swim team pool, or they use it for competition. Now, what would Sam maybe want to know about this pool with the black line? What could Sam's question be? Stop the video and think to yourself, what might Sam want to know about that black line? Now, if you said Sam wants to know why it's there, that's not really going to be a question we can answer with math, and I've already kind of answered that question for you. If you don't have a math type question, stop the video again and think, what kind of math question would Sam want to know about this black line? Okay, many of you probably said, Sam wants to know how long the line is. But where is that line located in the swimming pool? Is it on the top? Is it on the side? If you're thinking about it, that line is at the bottom of the pool. So Sam wants to know how long the line is at the bottom of the pool. Do you think Sam can get a yardstick out or a tape measure and go to the bottom of the pool and measure that? Maybe if Sam had like some goggles and a friend, and the friend could hold one side and he could hold the other. But if you're trying to measure the line and you're measuring on top of the water, your tape measure could be floating and that could add to the length. So he wouldn't really get a good measurement there. But Sam noticed that on the side of the pool, so on the side of the pool, Sam saw some tiles, like maybe the tiles in your bathroom. This pool has a pretty mosaic tile around it, okay? And these tiles go all along the edge of the wall. And think about that concrete black line goes from one wall to one wall. Could Sam use those tiles? He could. He could say, oh, this line is 10 tiles long. But is that going to help him get a metric measurement? When I say metric, I mean within our, I know we don't use meters and centimeters very often, but that's what I'm talking about when I say metric, or an inches or foot measurement. No, he would know how many tiles. So let's say there are 9 tiles. Sam counts 9 tiles that are 5 meters long. Who is the long pool? So, can I find out now with the information that I have, can I answer the question of how long that line is? So let's go back. Sam sees a black line on the bottom of a pool. I really like to draw things out when I'm drawing that picture helps me. So I'm just going to go ahead and draw the pool. Most pools are like this, especially one. So Sam has seen this black line on the bottom of the pool. Sam wants to know how long the line is at the bottom of the pool. Okay. On the side of the pool, Sam has saw some tiles. And Sam saw how many tiles? He saw 9. So I'm going to do my best to divide these into 9 equal pieces. Oh, that's not going to be good. I got to go back. Let's see. Did you see how many times I went back and counted to make sure that I only had 9 pieces? And my pieces are not totally equal, but I did the best I could. And I went back and I said 1, 2, 3, 4, 5, 6, 7, 8, 9. What do we know about these 9 tiles? They each measure. So 1 tile equals 5 meters. So I'm going to go and I'm going to label each of these 5. I'm not going to, if I have room to write meters, I'll write it, but down there it's hidden. Each measures 5 meters. Could I come up with an equation here? Stop the video and see if you can write down an equation to help you solve this. If you said 9 tiles times 5 meters, that would be a great equation to help you solve this. And 9 times 5 would be 45 meters. 45 meters. So what is the length of the black line? 45 meters long. Sam's not a very good swimmer. He couldn't swim the whole length of the pool. He was only able to swim 5 tiles. So Sam swam just to all 5. 5 tiles. What fraction of the length of the pool could Sam swim? What fraction did Sam swim? I want you to stop and think about it. Stop the video. Try to figure out what fraction of the pool did our friend Sam swim. Now, we use these tiles to count the pieces of the pool. How many tiles were there? 9 tiles. How many did he swim? 5. So Sam was able to swim 5/9 of the pool. How many meters did Sam swim? If we knew he swam 5/9 and each ninth counted for how many meters? 5 meters. 5 times 5 is 25. 25 meters. I'm going to ask one more question. I'm sorry, I know I'm asking a lot of you today. If Sam swam 25 meters, did Sam at least swim half of the pool? If the pool's 45 meters long, what is half of 45? I really want you to stop and think about what is half of 45? Can I divide 45 in half equally? And I have a feeling a lot of you are saying no. Because if I think about this, I'm kind of thinking there's a 40 and a 5. And I know I could automatically divide that 40 in half, which would be 20 and 20. But I've still got that 5. Can I divide a 5 in half? Now that I know about fractions, I can. Because I know inside that 5 there's a 4 and a 1. And I can always divide a 4 in half. That's going to be 2. Can I divide a 1 in half now? Oh, sorry. Missed it away. I can. So, for Sam to swim half of the pool, he would have had to swim 22 and a half meters. Sam swam 25 meters. Did he swim at least half of the pool? He swam a little over half of the pool. And those are just some ways that you can apply fractions in everyday things that you're doing. I hope everyone has a great day. If you have any questions about fractions, please feel free to call me or Miss Stendelbeck or Miss Christopher.